So we're going to investigate this formula, y equals a sine x minus c plus d. So we want to look at what does each variable do. So the first thing we want to do is make sure all our calculators are in the right mode. Okay? So with your graphing calculator, can you please turn your mode to radian if it isn't already? So the mode button is beside second, and just make sure the radian is highlighted if it isn't already. Okay? The next thing I want you to do is go to your windows. Okay? And type in the following: negative 2 pi, and pi over 2 for your scale. And then we're going to go negative 2 to 2 for our y min negative 2, y max 2, and then a scale of 1. Pi over 2. So pi divided by 2. And it'll change it to a decimal for you. Okay? Alright, and then what I want you to do is now graph y equals sine x. So go to y equals pi over 2. Oh, it's because you... And then this one has to be positive 2. And there you go. And negative. No, it just changes it to a decimal for you. Yeah, so it doesn't keep it in terms of pi, it just actually multiplies them. Okay, so graph y equals sine x. And we're going to sketch this. Okay, so if you need help, just let me know. Now it should work. Sine x. Right, type in y equals sine x, and let's draw this, okay? So let's do a quick sketch. So here we have, it's going from 0 to 2 pi, and then negative pi, negative 2 pi. Yeah? What? Oh, sorry. So it's going to be at pi over 2, it'll be 1, 3 pi over 2, negative 1. And then negative pi over 2 be negative 1, and negative 3 pi over 2. So just a quick sketch. Okay, so now I want you to graph. It's going to be helpful if you have different colored pens. So I'm going to do this one in purple. Y equals 2 sine x. So back to your y equals. And now I want you to type in y equals 2 sine x. You might want to make it bold so you can go over. And once that's flashing, if you push enter once, it'll make the line bold. So you want to make them different. Okay. And so what's the difference here? It's twice as high and twice as low, okay? There's a name for that. I'm going to make this one red. So the intercepts are still the same. But now instead of going a max of 1, it goes to max of 2 and a min of negative 2. So maybe we should label this on our graph as well. So please write in y equals 2 sine x so you can see the difference. If you're not using different colored pens, label the graph so you know which one's which. And this purple one was y equals sine x. And then one more graph. Maybe what you can do is delete the 2x and change that to the 0.5 sine x. Oops. So we'll just compare it to the regular graph. So the 2 sine x was twice as high. What's happening? So here's our original y equals sine x. What's happening to y equals half sine x? It's half as high. Okay, the max is 0.5 and the min's negative 0.5. So I'll use blue. Okay, so sketching again, the x-intercepts are the same, but now my min is at a half or negative a half, and our max is 1/2. So there you go. Okay, so which value were we working with the A value here? This is A, when we look at the formula, it's the A. And so there's different things to describe it. So instead of saying it's twice as high or half as high, what property that we learned about yesterday is changing? The amplitude. Yeah. What has changed? The amplitude has changed. Also, the max and the min value. We'll do regression stuff too later on in sinusoidal as well. Okay, so the amplitude has changed. Also, the max and min values have changed. So that's what the amplitude does. What if there's a negative sign in front? How would that change our graph? So what I'd like you to do is go back to y equals, clear your second graph, and the first we're going to graph is negative sine x. So what does a negative do? Okay. Push graph. So what's different about this graph and the one we just did? Start to the bottom, it decreases and then increases instead of increasing and then so it's going to go to our min first and then our max. It's almost like it's reflected. That graph was reflected in the x-axis. So let's sketch that really quickly. So our intercepts are at pi apart, and then this time at pi over 2 it's at -1, and then it goes to +1. So it goes like this. On the other side, it would be +1 here, -1. So that's y equals sine x. Negative sine x, sorry. So the difference between our first graph, the purple here, and this one, y equals negative sine x, is notice this one went up and then down, and this is going down, then up. It's the opposite, yeah. So it's like it's reflected in the x-axis. Another way you can think about it. Okay? So it's flipped or reflected. So one thing that's changed compared to the original is that it's flipped or reflected in the x-axis. Okay, it's like it's flipped over the x-axis or reflected over the x-axis. So -2, let's graph that one. -2 sine x. Sine, there you are. And if you want, you can make it bold. So go over to there, push enter, and then graph. So again, it's still flipped, but is the amplitude, what's the amplitude now? How high is it going to go? The second graph? If this one's a height of 1, what's the height of this guy? 2. The amplitude's 2 again. So same graph, but now we're going down. X-intercepts are the same. Okay, do we even need to put the other one in our graphing calculator? No. So what would be what is it going to look like? What would -1/2 sine x look like? The amplitude would be what? It's still going to be flipped, and then the amplitude would be? Anyone know? What does the A value do? So this flips it, the negative flips it, and then what does the A value do? What does it tell you? Your amplitude. It tells us our amplitude. Okay? It tells us our max and min, right? So our amplitude is only be 1/2. It's only half as high. I should probably go a little higher than that, but yeah, I'm a little lower. -0.5 sine x. Okay, so the A value of the graph is equivalent to the amplitude of the graph. Our A value tells us our amplitude. And if A is negative, then the graph is flipped about the midline. reflected about the midline. Okay, so what's nice about the A value, just going back up, is it starts with A and it's related to amplitude. So that's easy to remember. A stands for amplitude. Okay, and amplitude, remember, is a distance between our midline. Right, our A value is always the distance between our midline and our max. Okay? All right, next page. B value. So what is B value related to? Well, let's graph y equals sine x. Go back to your graphing calculators. So y equals sine x. And then the second graph we want to graph is sine 2x. Okay? And make that bold. We're going to graph each of these. The sine x, we know what that should look like. Here's pi, 2 pi, negative pi, negative 2 pi. And our amplitude's 1. And negative, max is 1, min is negative 1. Okay, so we're always going to be comparing it to the original y equals sine x equal every time to figure what the variables are doing. So there's our first graph. When you look at your graphing calculator, what happened now? It came compressed. Yeah, we compressed it. So if we think about it this way, in 2 pi, normally how many rotations do we have in 2 pi? What's our period of a regular 2 pi? Right. So it has 1 rotation in 2 pi. Now, how many rotations does it have in 2 pi? 2. So the B value is related to period. So the B value, it tells you how many rotations in 2 pi. And so this one had 2 rotations. So if we graph this, our period is now going to be, instead of 2 pi, if we're going to do 2 full rotations in 2 pi, our period is now pi. So our graph, and our midlines here, is going to look like, so this is 1 rotation. 1 rotation, oh, that was, here, I'll give you this. Okay, so if we have 1 full rotation, remember in 1 full rotation, we're at our midline 1, 2, 3 times. The first time, halfway between the 2 midlines, we're at our max, and then halfway we're at our min. And then 1, 2, 3, halfway between our first midline, 2 points, we're at our max, and then halfway we're at our min. So that's that side. Yes, Kamisha? Oh, sorry, that's the second graph, yes. Because we have because the B value is 2, that means we have 2 rotations in 2 pi. So if I was to graph the next guy, it's going to be a full rotation on this side. In 1 full rotation has to be between 0 and pi. So we'll get to our midline halfway again at pi over 2. Now this time on this side, is it going to go down here at this portion here, or is it going to go up? What would make sense? We're going to follow that pattern. Would it make sense to go like that? Does that look right? No. Oops. Undo. We'll be at our minimum halfway here, and then we'll be at halfway between those 2 points. We're at our maximum again. And then 1, 2, 3, halfway, we're at our min. Halfway, we're at our max. So what's changed on this graph? What's changed? Because yesterday we studied amplitude, midline, we've studied period, we've studied range. What's changed? The period. The period has changed. Now what's my new period of this graph? Y equals sine 2x. What would be pi? Okay, versus the original was 2 pi. So the period has changed. When you look at y equals sine x, the period was 2 pi. And y equals sine 2x, the period is pi. So here's a really important formula. Okay, it says for each equation, calculate 2 pi over b. Okay, so what I want to show you really quickly is on your formula sheet, there's only 2 formulas for this unit. Okay, there's the general formula that has A, B, C, and D, just so you can look at it and remember, okay, where's A, where's B, C, and D. And then there's this formula for period, and period is equal to 2 pi divided by the b value of a graph. Okay, so in this example that we've done, we're going to calculate the period. So we could have also calculate the period using the formula 2 pi over b. That's something that's really important. Period equals 2 pi over b. What's the value of y equals sine x? You don't see it. What's the coefficient in front of x? B is 1. So the period would be equal to 2 pi divided by 1, or 2 pi divided by 1 is 2 pi. Okay. For the equation y equals sine 2x, what's the b value? 2. So the period would be 2 pi divided by my b value of 2. And what is 2 pi divided by 2? 1 pi. Okay, and we can see that our period was pi for the graph y equals sine 2x. So the nice thing about the b value, if we know it, we could actually calculate our period. You don't actually have to look at the graph. We could calculate it as well. So in this graph, should we skip this one? Do we know what b value does? Let's go down to the bottom. Yeah, it's going to be farther instead. Because let's look at this. Let's calculate what the period would be here of y equals sine 0.5x. Okay, what would be the b value of y equals sine 0.5x? What's the b value? The coefficient of x. 0.5. So if I was to calculate 2 pi divided by my b value of 0.5. Okay. Now, in your calculator, how would you type that in? 2 divided by the 0.5. We don't want to actually put in the pi, because we want it in terms of pi. So 2 divided by half gives you, so it'd be 4 pi. Okay, so if we just did a quick sketch of this, this was pi, and this was 2 pi. This is negative pi, and this is negative 2 pi. Remember our original graph looked really quickly. We'll just draw it really quickly. Okay, that was y equals sine x. So y equals sine 1/2 x. The period is 4 pi. So what it's saying is, remember the b value is the number of rotations in 2 pi. So it's only doing 1/2 a rotation in 2 pi. So in 2 pi, it doesn't do the full rotation. It's only going to do half of a rotation. And then so if we graphed it on our calculator, that's what it would look like. Because it only does half a rotation in 2 pi. We don't even need our calculators now that we understand that. So bigger than 1, then it's compressed, like you said. when it was smaller than 1, like the 1/2, what happened to our graph here? Did it expand or was it compressed? It was expanded. Yeah, because our number of rotations in 2 pi is going to be less. And then if it's a b is negative, then it's reflected in the y-axis, which you probably won't see a negative b value. Okay? All right. So remember the original formula. I know there's a lot here today, but that's why you're going to have a work period in a couple days. There's a 2-part lesson and then a work period attached to this, okay? I don't think the original, yeah, it did. Now, on your diploma, there's not going to be a big emphasis on the C variable unless you take 30-1, but we still want to have a general idea of what C does, okay? So the C value is it's something to be added or subtracted. That's the C value. Okay, so let's graph the original graph first, y equals sine x. You could probably graph that without actually putting in your calculator, right? Pi, 2 pi, negative pi, negative 2 pi. Starts at 0, 1 full rotation's 2 pi, back to our midline at pi, and we're at 1 and negative 1. There's 1 rotation and 2 rotations, okay? So it's always good to have that in your calculator just so we have something to compare it to. And then type in sine x plus pi over 2. And graph. Oh, did you make yours bold? It's helpful. Okay, was this graph stretched in any way? Vertically and horizontally? No, it's not stretched. It's the same shape. What happened to this graph? It's just, what? It's starting at a different point. It was just shifted. It's called a phase shift. So the C value is actually going to be a phase shift, what we call a phase shift. It shifts the graph left or right. Okay? Now in this case, did the starting point shift to the left or to the right? It's the closest point so that it repeats itself, the same pattern. So we have to go way over here, like it's right here to the left, right? We can see it moved to the left, and it actually moved to the left pi over 2 because that's the units. So this, if it's a plus pi over 2, it means it's shifted pi over 2 to the left. I'm going to graph, let's use blue. Remember, this is negative pi over 2, negative 3 pi over 2, pi over 2, and 3 pi over 2. So we're going to take our graph and shift all our points pi over 2 to the left. So this point here moves there. Okay, this point of pi over 2, where is it going to be now? At x equals 0. This point, shift it to the left, pi over 2. Our negative 1, shift to the left to the pi. And then 3 pi over 2. So there is going to be, it's shifting our graph pi over 2 to the left. I'm moving it that direction. And then just take the rest of your points and just shift them. And we can just start this one off again. There you go. So there, it's purple or blue. Purple. So what's changed? Well, what's different? The x-intercepts, are they different? Yep. X-intercepts and y-intercept have changed. So the graph shifted. Well, I wrote that already. The graph shifted pi over to the left. So what is the new starting point? The new starting point of this function. So it used to be 0, 0. Now it's what's this point right there? 0 and 1. So this is 0, 0. And now the y-intercept is 0, 1. Okay, I think we'll skip the next one. The only difference is if it's a minus sign, then it's going to move to the right. So notice how if we had plus, it moved to the left. So it does opposite. And if it's a minus, it's going to move to the right. So this would move pi over 2, shift pi over 2 to the right. Okay. Yeah. The C value isn't as important. You have to have a general idea of what it does, but it's a shift, okay? And the signs are opposite. So if I had a graph, for example, let's say I had y equals sine x minus pi. What would be the shift? Pi to the, so we'd shift pi to what direction? If it's a minus, right, it does opposite. Okay. If I had an equation that said y equals sine, let's say x plus 3 pi over 2, well, let's actually make this pi over 4. Plus pi over 4, what would be our shift? It would shift pi over 4 to the left. So you'll notice the things that are attached to x kind of do opposite, right? The C value, if the sign is minus, it goes right. If it's plus, it goes left. We saw the B value, which is attached to the x on the previous page. When our B value was 2, it actually made it more rotations. It compressed it. Where if it was a small b value, less than 1, it expanded it. So when you're attaching things to x, it actually often does opposite of what you might think it would do. So I'm just going to, does everyone have that down? Just really quickly. When we looked at this b value of 2x, notice a 2x compressed our graph, right? It gave us a compression. When we had half, it actually did what? Expanded it. So these things that are attached to the x, the inside of our sign, often do opposite. And there is a reason for that. But so if we had a minus sign, it moved to the right. If it was a plus sign, it moved to the left. So let's just a horizontal shift. If it was plus C, we saw plus something, it shifted to the right. And if it was, oops. Oh, this is a yeah, left, sorry, right. Thank you. It does opposite. And then if it becomes, let's rewrite this to y equals sine x minus c, then it would move to the right. So let's take away the negative. Okay. So ignore the negatives. Just so if it was at y equals sine x minus c, then it would move to the right. Okay, so last one variable that we have to look at is d value. So d value is technically, if we're looking at that equation again, a sine b x minus c plus d. Sometimes you'll see x plus c or x minus c. Doesn't really matter. B and c were associated with the x value, right? It changed mostly our x-intercepts. It shifted things. or it made more rotations. So it really affected the x. A stretched it vertically, affected the y, and D is also affecting the y. They're on the outside. They're associated with y. So let's graph y equals sine x and then sine x plus 1. Notice the difference between the c and the d value. The c is inside of the sine, whereas the d is outside. You have to close that bracket. Our first graph, y equals sine x. Our second, y equals sine x. Close the bracket this time, plus 1. So we're not putting the plus 1 inside the brackets. And then graph them. So start by sketching your sine x. So halfway between your first midline points, or your x-intercepts, is your max. And halfway between your other x-intercepts is your min. And then here. There we go. Okay, so let's graph what happened. Let me look at your graph. What happened? Ooh, moved it where? Up how much? Shifted the graph 1 unit up. Shifted the graph, or you could say translated the graph, or moved the graph, or whatever. Shifted the graph 1 unit up. So it affected our max and min values. So our max and min values are going to change. Our intercepts will also end up changing because we're moving it up 1. So everything we're going to move up 1 unit. All our points, move them up 1. So everything that you had here, just move it. So once you've graphed your sine x, move everything up 1 unit. And then you can connect the dots. It was ugly. Okay. Y equals sine x plus 1. Okay. So now, what's the midline? So the midline for y equals sine x. What's the equation? The original. Y equals what? What's the midline at? Quick, guys. What is it? Where's the midline for the original? 0. And the new one, what's our new midline? Sine x plus 1 is y equals 1. So what that d value does is it tells us our midline. Okay, it shifts the graphs up or down, and so that changes the midline of the function. Our d value is our midline. So what would happen to this graph here? It would move 1 down. So if we just did a really quick sketch of regular sine x, so it would just move everything 1 unit down. So it would be like that. Okay, that's not right. Something's wrong here. This would be here, down 1, down 1. There you go. Down 1. There you go. Okay, so minus 1, that our midline's now going to be at y equals negative 1. So our d value shifts our graph up and down, and it changes the midline. So the median would be at negative 1. So really quickly, if d is positive, it's going to shift it up. And if it's negative, it shifts it down. Okay, I do have a quick review of everything that we'll go through tomorrow, but we'll leave this lesson here. Okay, and just stop the recording for a second.